Welcome to Classwork 6.2, section 4.6. Let's start by going straight to example 4. We're going to use the graph of y equals 2 sine 2x to figure out the graph of y equals 2 cosecant 2x. So first, we're going to note all the zeros here. So that's step 1. Mark all zeros. So step 1, mark all zeros. Because if you think about the zeros, the sine graph and the cosecant graph are reciprocals. So if you think about 0, the reciprocal of 0 is 1 over 0, which is undefined. Which means on the cosecant graph, all these zeros are undefined, which makes them asymptotes, like that. So let's mark those. Now remember, our goal is to graph y equals 2 cosecant 2x. So first I'll just show you how it works, and then I'll kind of explain how it's working. You're going to mark the max and mins. So now I'll mark the max and mins here. So in step 2, mark max and mins. Now what happens is, if you imagine each of these parts right here, I'll highlight this. Imagine you take the reciprocal of that. So essentially it's going to flip it and make it into a parabola. So your graph for cosecant is a whole bunch of parabolas. And hopefully you recall that from your trig class. And there it is. That's your cosecant graph. Now for one period, I'll highlight this for you. Here's our box. This right here is going to be one period. Notice how it is two parabolas. Okay, and that's pretty much how you graph it. Now, if you think about why that happens, if you think about the unit circle, and before that, actually, I'll finish up. Step 3 is simply graph the parabolas. So you'll see that to graph these is pretty quick. But the theory, so if you think about the unit circle, so there's our circle. The max for, let's say, a sine graph, here's our max equals 1. Here's our min, that's -1. If you take the reciprocal of 1 and -1, notice how they don't change. The reciprocal of 1 is 1. The reciprocal of -1 is -1. And that's why the max and min points on the cosecant graph are also unchanged. So those points also exist on the cosecant graph. And that's why it's a really simple way to use those points to find the cosecant or secant graph. So that's it. Let's quickly do domain and range. Domain, range. The domain is going to be all x such that x cannot be pi over 2 plus pi over 2k. And the range is going to be -infinity to -2, union 2 to infinity. Notice how the 2's are inclusive. For your note, just notate this thing right here. That's going to be any asymptote. And this part right here this is going to be 1/2 the period. Because notice how the asymptote cuts exactly half the period. So if you look at this part right here, that's exactly half the period. And if you want to be fancy, you can do something like this. X such that x cannot be pi over 2k. Because you can think of 0 as an asymptote, but you don't have to do that. You can just do the one I wrote earlier. And there's your domain, there's your range. Not too bad. So now let's try the example right below it. We're going to start by doing the exact same thing we always do. Start by putting a t here. I'm going to go 1, 2, 3, 4. So the setup is pretty similar. Your amplitude and period are just like you were doing earlier. I'll put that on the side actually. Amplitude is 2, the period's going to be 2 pi. Except this time you want to put your a values a little bit in the middle like that, so 2, -2. And then our period, same thing. Let's put 2 pi, pi, pi over 2, 3 pi over 2. Now you don't have to do this, but a lot of people like to sketch the sine wave. So they'll do like a dotted line like this. But again, you don't have to do this. After that, just follow the steps I listed earlier that are up there. Mark the zeros. So I have a 0 here, 0 here, 0 here. Those zeros become asymptotes. So asymptote, asymptote, asymptote. Mark the max and mins, so they're those two right there. Now graph your parabolas. And there you go. Look how fast that was. So that point, let's label that. That's pi over 2, comma 2. This is 3 pi over 2, comma -2. Now for domain and range, let's be clear here. That's important to understand. So domain, range. The range should be pretty easy. It's just like the last problem. -infinity to -2 inclusive, union with 2 inclusive to infinity. Now the range, domain, let's put our fancy bracket, x such that x cannot be. So pick any asymptote. You could pick 0, you could pick pi, 2 pi, 3 pi, whatever. 0 plus. Now notice the distance between each asymptote. That's this. That's pi, or 1/2 the period. So that's just pi k. And that's our domain. Done. So now let's try the next example. Let me draw a line right here for you. So we're doing the exact same thing with cosine now. So steps are similar. Mark the zeros. And notice how our goal is going to be graphing y equals 1/2 secant 2 pi x. The zeros become asymptotes, like that. And all we're going to do, mark the max and the mins, and sketch your parabolas. Now, what's important to understand or remember is that in your trig class, or pretty much any trig book, the graph's going to look like this. Notice how it's only 1/2 a full and a half. So just remember that is still a full period because it technically is still 2 parabolas. Now for the domain and range, very, very similar. The range, that looks pretty easy. Let's do that first. -infinity to -1/2, inclusive to 1/2 to infinity. The domain, I'm going to say all x such that x cannot be. Again, pick any asymptote. The first asymptote looks like it would be a quarter. So let's put x cannot be a quarter plus, and then half the period here, or this distance right there, that's 1/2. So I'll just write 1/2 k. And in case you forgot from your trig class, the k represents any integer. So essentially it's just saying multiples of half. So 1/4 out of half, so that's 3/4, 5/4, and so on. So notice how this asymptote right here, this is 1/4. This would be 3/4. And that's basically saying 1/4 and keep adding a 1/2. Okay, so that's it. So now let's try the final example. I'll draw a line right here for you. A3, period, 4 pi. We're going to draw our t right here. 1, 2, 3, 4. We're going to put our amplitude values. Make sure you put them maybe a little in the middle or higher than the middle. 3, -3, 0. And then fill it in. That's 4 pi, 3 pi, 2 pi, pi. We're going to start by sketching the cosine wave. Now, if you're really good at this, you could just draw these 5 dots, because those are like the 5 primary dots, and that's really all you need. Because from here we note that the zeros are going to become your asymptotes, so just draw those in. And the max and min points just tell you where the parabolas are going to be. So once you're really good at this, you could just do what I did just to save yourself some time. Now label 0, -3, 2 pi 3, 4 pi -3. And there's our graph. Now the domain and range, we'll do the domain first. All x such that x cannot be pi plus 2 pi k. So again, this one is any asymptote, and this one is simply 1/2 the period. And the range is going to be -∞, so -3 inclusive, union 3 to infinity. And there it is. Okay, good job. And let's start working on some other problems.